Right. So today we're really going deep on this one. Artificial intelligence, AI. It's everywhere now, and it seems like everyone's talking about it. But where did it all begin? We've got some really interesting sources here that trace the whole story back to like ancient myths, and then all the way to self-driving cars and stuff like ChatGPT. So hopefully by the end of this, we can kind of give everyone a clear picture of how we got here.
Yeah, it's fascinating to think about, those early ideas of artificial beings. Like in ancient Greece, there was this myth about Talos, this bronze giant that guarded the island of Crete. And then in medieval times, you had the Golem, this creature made of clay that's brought to life. Those early stories, they really show how long we've been fascinated by this idea of creating artificial intelligence.
Right. And it wasn't just myths, right? Like people actually tried to build these things early on.
Exactly. Like back in the 13th century, there was Ramon Lull. He tried to design what he called logical machines. It was basically an early attempt to formalize reasoning. And then a few centuries later, you have these heavy hitters in philosophy like Leibniz, Hobbes, Descartes. They were grappling with the very idea of thought and how to systematize it, really laying the groundwork for what was to come.
Okay, so we've got these philosophical roots, these early myths, and then what? When did things start to get really interesting?
Well, the 19th and early 20th centuries were really key. You start seeing these ideas reflected in literature, right? Frankenstein, of course, and then this play called RUR. It actually gave us the word robot. But just as important was all this work happening in mathematical logic. People like Boole, Frege, Russell, and Whitehead, they laid this incredible intellectual foundation. And that directly led to Alan Turing and his concept of the Turing machine, which is like the blueprint for modern computers.
Right, Turing. Everyone talks about the Turing test. Okay, so the groundwork is laid, but when does AI as a field really get going?
The 1940s. This is when things really start to come together. You've got all these different fields converging: neurology, cybernetics, information theory, and computation theory.
It's like the perfect storm.
Exactly. And that leads to some major breakthroughs. McCulloch and Pitts, they analyze artificial neurons. Hebbian learning emerges. And of course, Turing publishes his famous paper, Computing Machinery and Intelligence, which introduces the Turing test and really sets the stage for the field of AI.
Wow, so much happening in the 40s.
Yeah.
Then what? Do we start seeing the first AI programs?
Yes. So you've got these early programs for checkers and chess, the first neural net machine, SNARK, in 1951. And then in 55, this program called the Logic Theorist that could actually prove mathematical theorems.
No way. It feels like things are really taking off.
They are. And then comes this pivotal moment. 1956, the Dartmouth Workshop. This is where it all comes together. John McCarthy coins the term artificial intelligence, and it marks the official birth of AI as a field of study. Plus, this is happening right at the start of the cognitive revolution. It's like this huge shift in how we understand the mind and intelligence.
Okay, so the field is officially launched. It's the 50s. Everyone's excited. What happens next?
Well, from the late 50s to the early 70s, it's like this period of early flourishing. Programs are being developed that can solve algebra word problems, prove geometry theorems, work on calculus. There are early attempts at natural language understanding the development of semantic networks. Early neural networks emerge. Things are moving fast.
Sounds like it. But then what about this AI winter everyone talks about? Wasn't that in the 70s?
Yeah, so it became clear that there were some really big hurdles to overcome. Like these programs struggled with complexity, computing power was limited, and then there's this huge issue of common sense knowledge. Like how do you teach a machine all the stuff that humans just kind of know?
Right, that makes sense. So what happened? Did research just completely stop?
No, not at all. A lot of important theoretical work continued, like the development of the programming language Prolog. Marvin Minsky came up with the idea of frames for representing knowledge, and Roger Schenck worked on scripts for understanding stories. These were all crucial advancements, even though it was a bit of a quieter period.
So it was kind of a regrouping?
Yeah, I think that's a good way to put it. And then in the 80s, things heat up again.
The AI boom. Yeah.
Exactly. And this time it's driven by these things called expert systems, programs like Dendrel, MYCIN, and R1. They were designed to solve very specific problems in areas like medicine and computer configuration.
So it's becoming more practical, more real world.
Yes, and there was also a lot more government funding. Japan launched this huge initiative called the Fifth Generation Computer Project. You also had the ALVI project in the UK and the Strategic Computing Initiative in the US. AI was back in the spotlight. The first Area AI conference was held in 1980, and that really helped bring researchers together.
Okay, so AI is booming again. But hold on, wasn't there another AI winter after that?
Yeah, unfortunately, the boom didn't last. By the late 80s, early 90s, the market for specialized AI hardware kind of collapsed, and maintaining these big, expensive expert systems turned out to be really difficult. So funding dried up again, and there was another dip in enthusiasm. That said, research continued, but it became more focused on these smaller, more achievable goals, what people called narrow AI. And the idea of intelligent agents, software programs that can act autonomously started to gain traction.
Okay, so 2 steps forward, 1 step back. It seems like a bit of a roller coaster ride.
It definitely has been, but even during those quieter periods, progress was happening. And then starting in the mid 90s, things really start to shift again. AI starts to become more and more a part of everyday life.
This is when we start to see it in things like, search engines and stuff.
Exactly. But first, there's this big symbolic victory. 1997, Deep Blue, this chess-playing computer developed by IBM, defeats Garry Kasparov, the reigning world chess champion. It was this huge moment that captured the public's imagination. And then after that, you start to see AI creeping into consumer products. Like in 2002, the Roomba vacuum cleaner comes out. And speech recognition software gets a lot better. NASA uses AI in its Mars rovers. By the mid-2000s, major tech companies like Twitter, Facebook, Netflix, they're all using AI behind the scenes.
So AI is kind of everywhere, but we don't always realize it.
Right, it's becoming more integrated into our lives. And then in 2011, there are two big public-facing breakthroughs. IBM's Watson wins Jeopardy, beating these two really good human players. And then Apple releases Siri, the voice assistant on the iPhone. These were huge milestones that brought AI into the mainstream.
Okay, so that brings us pretty much up to the present, and now we're in this era of deep learning and generative AI, right? It seems like everything's changed.
Yeah, the last decade or so has been completely transformative. What's fueled this latest boom is the combination of two things: massive amounts of data, what we call big data, and much more powerful computers. And that's allowed this technique called deep learning to really take off.
Deep learning that's
Yeah.
basically using these artificial neural networks, right?
Yes, exactly. And a key moment was in 2012 when Google demonstrated a deep learning system that could recognize cats in YouTube videos. It sounds simple, but it was a major breakthrough. Since then, deep learning has revolutionized all sorts of fields: image recognition, natural language processing, machine translation, and it's led to these incredibly powerful models like GPT-3, which can generate human quality text and code. And then there's DLE, which can create images from text descriptions, and of course, ChatGPT, which everyone's using now. Even the Nobel Prizes have recognized the importance of AI research, with awards in economics and computer science going to pioneers in the field.
So it's safe to say that AI is kind of a big deal right now.
Yeah.
But what can it actually do? Like, what are its core capabilities?
Well, right now, AI systems are really good at certain tasks, like perceiving the world through sensors and cameras, understanding and generating human language, analyzing huge amounts of data to find patterns, and making recommendations based on that data. Both NASA and IBM define AI as systems that can perform tasks autonomously and learn from experience. And the key techniques they use include machine learning, deep learning generative AI, and reinforcement learning. It's important to remember that what we have now is what's called narrow AI, or ANI. It's good at specific tasks, but it doesn't have general intelligence like humans do. There's a lot of debate about whether we'll ever achieve AGI, artificial general intelligence, or ASI, artificial superintelligence, which would be even more powerful. But even with narrow AI, we're seeing a lot of benefits. Increased automation, which can make things more efficient and less prone to human error. It can free up human workers to focus on more creative and strategic tasks. Data analysis is becoming much faster and more accurate. Systems can operate continuously, and it's accelerating research and development in all sorts of fields.
And what about these GPT models that are powering things like ChatGPT? How do they actually work?
So GPT stands for Generative Pre-trained Transformer. It's a type of deep learning model that's really good at understanding the relationships between words in a sequence. They're trained on massive data sets of text and code, and that allows them to generate really human-like text, have conversations, answer questions. They're being used for all sorts of things: building chatbots, summarizing long documents, writing different kinds of content, even improving search engines. The training process is incredibly complex, but basically the model learns these statistical relationships between words, and then it can use that knowledge to generate new text that follows those patterns.
So we've talked a lot about AI in our personal lives, but it's also having a big impact on larger systems like cities and even rural areas, right?
Absolutely. So in cities, AI is being used for all sorts of urban planning and management, optimizing traffic flow, managing energy consumption, improving public transportation. You see this happening in cities all over the world: Singapore, New York, Tokyo, London, San Francisco, Dubai, Shenzhen, Helsinki. And in rural areas, there's a lot of potential for AI to improve agriculture through things like precision farming. It can help with transportation logistics, improve access to education and healthcare through remote technologies, and even help with things like weather forecasting. But a big challenge in rural areas is internet access. Many communities lack reliable broadband, which is essential for taking advantage of these technologies.
Yeah, the digital divide is a real issue. But there are some initiatives trying to address that, right?
Yeah.
Like Starlink and some government programs.
Exactly. Bringing high-speed internet to rural communities is crucial for them to benefit from AI and other digital technologies.
Okay, now I want to talk about a specific AI that's been in the news a lot. Grok AI from XAI. What's the deal with that one?
So Grok is a large language model, kind of like ChatGPT. But what makes it different is that it's integrated directly with X, the social media platform formerly known as Twitter. So it has access to this huge stream of real-time information, which gives it a unique perspective. To use it, you need an X Premium Plus subscription, though. It's also been designed to be a bit more playful and unconventional than some other AIs. It has a fun mode, where it's more likely to make jokes and be a bit sassy, and then there's a regular mode for more serious tasks. While its capabilities are similar to other large language models, its real-time data access and its more casual, sometimes even rebellious persona make it stand out. And interestingly, the company XAI has open-sourced the underlying Grok 1 model, meaning that other developers can use it and build on it. They've also been adding new features and capabilities like image understanding and web search. Newer models, like Grok 2 and Grok 3, are also being released.
That's really interesting. And it seems like this whole trend of open source AI is becoming increasingly important.
It is. Open source AI offers several advantages. It allows for more customization. You have this whole community of developers who can contribute to the project. It's generally free to use. And there's more transparency about how the models work compared to these proprietary closed source models. We're seeing some really impressive open source models emerge, like Llama, GPT Neo, Bloom, and BERT. Each one has its strengths and particular use cases.
Now, one of the big ethical debates around AI, especially generative AI, is this question of AI art and whether it's stealing from human artists. What are your thoughts on that?
Yeah, this is a really thorny issue. The core of the debate is that these AI art generators are trained on massive data sets of existing images, many of which are copyrighted, and often the original artists haven't given their consent for their work to be used this way. So the concern is that AI can now produce art that's very similar to the style, even specific elements of human artists' work, and that could potentially harm their livelihoods. There's even been a lawsuit filed by the New York Times against OpenAI and Microsoft over copyright infringement related to AI training data.
That's interesting. So what's the legal situation right now? Seems like it's still kind of a gray area.
It is. The legal landscape is still evolving. Some jurisdictions are looking at ways to protect artists' rights in the age of AI. But in the US, the Copyright Office has generally taken the position that copyright protection applies only to works created by humans. So purely AI-generated art, where a human just gives the AI a prompt and it produces the output that's unlikely to be copyrightable. However, if a human modifies an AI-generated piece in a significant way, that human contribution might be eligible for copyright protection. It's an ongoing debate, and we'll likely see more legal challenges and possibly new legislation as this technology develops.
Okay, so looking ahead now, what are some of the big advancements we can expect in AI in the future?
Well, one thing is for sure. AI is going to become even more integrated into our lives. We can expect to see much more sophisticated AI-powered tools for things like business automation, which could lead to major shifts in the job market. There's going to be a lot more focus on data privacy and the ethical implications of AI, so we'll probably see more regulation in that area. AI is also being explored as a tool to help address climate change and other big global challenges. And overall, the pace of innovation in AI is only going to accelerate. We'll likely see AI playing a much bigger role in our daily lives, from helping with things like elder care and managing household tasks to improving efficiency in the workplace. The underlying machine learning models are going to get more and more powerful. We'll see advances in natural language processing, computer vision, and other areas. And there's a big push for something called explainable AI or XAI, which means making these systems more transparent so we can understand how they're making decisions.
Now, there's been a lot of talk about quantum computing and how it might impact AI. Google's Willow quantum chip has gotten a lot of attention. What are your thoughts on that?
Yeah, so the Willow chip is a significant step towards building more powerful and reliable quantum computers. Right now, quantum computers aren't quite powerful enough to break the encryption methods that are used to secure things like cryptocurrencies. But it's something that people are keeping an eye on because, in theory, quantum computers could be used to run algorithms that could crack those codes. But for AI specifically, the real potential of quantum computing is in the sheer processing power it could offer. In the future, quantum computers could be used to train incredibly large and complex AI models that are just beyond the capabilities of classical computers. That could really accelerate progress in AI research.
We got a listener question about AI and humor. They want to know if AI can actually be funny. Can it tell jokes?
Pause. Well, that's a tough one. AI can generate text that's structured like a joke, setup and punchline. But true humor relies on so much more than that. It's about human experience, emotions, understanding social context, and cultural nuances. And that's really difficult for AI to grasp. There are some AI joke generators out there, but the results are often pretty hit or miss. They might rely on simple wordplay or puns that don't really land. Some people even find AI-generated humor a bit unsettling rather than funny. It's like something's just a little bit off. So while AI can mimic the form of a joke, capturing the essence of what makes something truly funny, that's still a big challenge.
So to wrap things up here, it's been quite a journey tracing the history of AI from those early myths and philosophical ideas all the way to the incredibly sophisticated systems we have today.
And it's fascinating to see how AI has gone through these cycles of hype and disappointment. But the progress we're seeing now, especially with deep learning, it feels more substantial, more impactful than ever before. AI is clearly here to stay, and it's going to continue to transform our world in profound ways.
Definitely. And as we look to the future, there are all these exciting advancements on the horizon. But there are also some big questions that we need to grapple with about ethics, about the impact on society. It's going to be a wild ride.
It is, and I think it leaves us with a really important question to ponder. As AI becomes more and more integrated into our lives, how will it reshape our understanding of what it means to be human? How will it impact our creativity, our ingenuity? These are questions that we'll all need to think about as we move forward into this new era of intelligence.